All right, so this is our last video for today. This is our math video. So you should have already gone through your checklist that you jotted down this morning, and this is gonna be our math video. So today is March 25th, 2020, and I'm gonna start by sharing my screen so that we can go over our anchor chart like we typically do. And remember, if I do the gesture and I say the word, you say the word at home. I'm gonna make my screen bigger so you can see the words. So say it with me: multiply, equal groups, number of groups, multiples, group size, factor times factor equals product, equation, commutative property, associative property, efficiently. I think the product is because array, rows horizontally, columns vertically, decompose distributive property. For our models and our strategies, we have the ones that we've typically used more so at the beginning. We have repeated addition, we have skip counting, array model, decomposing, which is the same as distributive property. That's what we've been learning these last few days, and our area model that I introduced this week. So we're actually going to start with a do now. I read this online and I thought it was interesting and I wanted to share with you guys. Plus, how cute is Miss Delgado and my Bitmoji with the penguin. It's pretty cute. So, did you know most penguins swim underwater at around 4 to 7 miles per hour? But the fastest penguin, I think it's pronounced Gentoo, the Gentoo can reach top speeds of 22 miles per hour. So our do now has to do with this type of penguin. There are 5 Gentoo penguins at the Long Beach Aquarium. If each travel 22 miles per hour, how many miles in total can all 5 Gentoo penguins travel? Use the area model and distributive property to solve. You can use a second strategy to solve. So right now I'm going to ask you to make sure you have your math notebook out, and you're going to copy down what I have highlighted in yellow, and I'm going to give you, well, you have unlimited time, right? So if you need 5 or 10 minutes, that's how much time you're going to use. But you're going to pause me, you're going to write down the problem, and you're going to solve. Try using the area model and the distributive property to show how you solved. And go do that now. All right, so you should have already solved, and let's see. I'm going to read it again, and then I'm going to take out my smart file so I can do the work and you can see the work. There are 5 Gentoo penguins at the Long Beach Aquarium. If each travel 22 miles per hour, how many miles in total can all 5 Gentoo penguins travel? So I'm going to stop share of this screen so I can switch over to the other screen. So 1 second while I do that. And this is going to be for later. So hold on, let me scroll up. So if we go back, right, if we think about the area model, it's very similar in the way that it looks to an array model. And we have bigger numbers. We have a single digit number, which is 5, and we're multiplying that by 22 because it's asking us how many miles did these 5 penguins travel, and each of them traveled 22. Sure, I could do 5 groups of 22 and solve that way. That's one way to solve, that's repeated addition. But I really want us to practice using the area model. Obviously, it's so much easier to draw this out in class on the smartboard or on the easel, so it's a little bit harder for me to do here. But if you had a hard time doing the area model, make sure you copy it down with me. And if you did do it, see if your answer compares to mine. Is it correct? And so I'm going to use my rectangle shape to draw out my area model. So I have 5 times 22. Actually, I'm going to start by writing my equation and my distributive property. So I have 5 times 22, and let me see, how am I going to decompose that? I'm not going to decompose the 5 because that number is already a friendly number, but I am going to decompose that 22. I might decompose it like this: 5 times 20 plus 5 times 2, right? Because I'm decomposing the 22 into a 20 and into a 2, and I'm multiplying it by the other factor. I'm gonna make this a tiny bit smaller so I can have more space to do other things. So that's my equation, and now I'm gonna represent that equation with that area model. So now I do need my rectangle so I can show you guys how to do that. Let's see. So I'm going to start by multiplying 5 times 20. And then I need a smaller rectangle. And let me see if I can choose a different color so I can show it. Maybe it'll be easier. Yep. Oh, perfect. Okay, it's not perfect. Doesn't look perfect, but you get the picture. Let me see if I can make it a little bit smaller so it fits better. And yeah, okay. So I'm gonna write on the side, right? So this is, I'm gonna represent this as 5 times 22. So 5 times 20, because I'm using the distributive property. And that's gonna be easier for me to solve. And then 5 times 2. Okay, so now 5 times 20, right? I can count on my fingers, 20, 40, 60, 80, 100. Or I could have said to myself, well, 20 is a multiple of 5, so I can really just multiply 5 times 2, and that gives me 10, and I have that 0. So I'm just gonna bring that down, and that gives me 100. See, there's many ways you can do it. So this is 100. And now I have 5 times 2, which is easy peasy because we do this all the time. 2 equal groups of 5 gives me 10. So then I'm putting 10 down here. Now, what do I have to do with these two products? Well, I have to add them, right? Because I've decomposed the number. I have, I say, you say, I have partial products. And when I say partial products, I mean this is part of the product, of your total product. We decomposed it, we use the distributive properties, so we can find partial products and then add those together. This strategy is going to be so helpful when you're multiplying double-digit numbers by double-digit numbers, so it's really important that we practice it. So now we have 100 plus 10 is 110. So really, right, these Gen 2 penguins, let's write a statement. These Gen 2 penguins, let me make this small because it likes to make it big. The 5 Gen 2 penguins traveled 110 miles per hour, mph, so miles per hour. So give yourself a big check mark or a little pat on your shoulder if you're able to answer that correctly. This is what I really want you guys to push for, is using partial products, right? So partial products are those part of the product that you get when you use distributive property. Use that distributive property equation and use that area model to show that you understand distributive property. So the next thing that we're gonna do, I'm gonna stop sharing the screen for a second, and then I'm gonna share my other screen so we can look at what's next on our math, or for our math lesson. So now we are going to do a little Number Talk SBAC review. So yesterday we did something very similar. It was from the test, and then I made up my own question. And I'm featuring our good friends Janet from Ms. Delgado's class and Ingrid from Mrs. Alonso's class. So Janet and Ingrid buy a box of donuts, yummy. They count the different number of donuts they eat in one day. They each use a different method to find the total number of donuts they eat. So let's just look at the table. First of all, there's types of donuts. So we have a Boston cream, a glazed donut. Can you believe it? There's a donut called a bear claw. A bear claw donut because it looks like a bear claw, a strawberry frosted, and number of donuts that they ate. All together, they ate 3 from the Boston creams, 5 of the glazed, 5 of the bear claws, and 3 of the strawberry frosted. And so Janet's solution, because she wanted to figure out how many donuts they ate, she wrote 3 plus 5 plus 5 plus 3 equals 16, where Ingrid wrote in parentheses 2 times 3 plus 2 times 5 equals 16. And I want you to just pause the video right now and think to yourself, what are you noticing? What is a similarity between Janet's solution and Ingrid's solution? Pause me now so that you can think about it. All right, and you're back. Maybe you said to yourself, well, a similarity between Janet's solution and Ingrid's solution is that they both have the same answer, right? So one person, Yanet, used addition. She added up all of the numbers together. And Ingrid used some type of multiplication equation in there to get 16. Well, now the question is, which equation shows why they got the same result? So A says 2 times 3 equals 5. B says 2 times 5 equals 7. C is 5 plus 5 plus 3 equals 2 times 3 plus 2 times 5. And then D is 3 plus 3 plus 5 plus 5 equals 2 times 3 plus 2 times 5. I want you to pause the video and eliminate at least 2 options that don't make sense. All right, you probably, I'm gonna stop sharing the screen and I'm gonna switch over so that you can see my other screen. And it sometimes lets me fast and lets me do it fast and sometimes it doesn't, but here we go. All right, so I'm scrolling down. You probably eliminated option A and option B. Why? Why did we eliminate those? Well, 2 times 3 equals 5, definitely not, right? We know that 2 times 3 is 6, so there's no way. And because we know 2 times 3 is not that answer, 2 times 5 equals 7, that definitely not, right? 2 groups of 5 is the same as 10. So really you should have eliminated those 2. Now let's look at option C and option D. 5 plus 5 plus 3 is the same as 2 times 3 plus 2 times 5. Well, over here we saw that this gives us 16, right? Because 2 times 3 is 6, and 2 times 5 is 10, and 6 plus 10 is 16. And here on the other side of the equation, we have 5 plus 5 plus 3, which gives us 13. 13 equals 16. Does it? Doesn't, right? That doesn't make any sense. So we can eliminate C. Well, now we want to look at, let me erase this part because I just crossed something out. Let's look at option D. 3 plus 3 plus 5 plus 5 equals 2 times 3 plus 2 times 5. Why does this make sense? Well, what Ingrid probably did is that she noticed, and I'm going to use a different color, she probably noticed that there's 2 groups of 3 and two groups of 5. And so she wanted to represent that as multiplication. Because 3 plus 3 is 6 and 2 times 3 is 6, right? There's 2 groups of 3 and then there's 2 groups of 5. And that is why D is the correct answer. And if you got that, give yourself a little pat on the shoulder. We'll be doing more of these questions where you're going to have to think about how did somebody solve that, right? Like critique the reasoning of somebody else's like mathematical thinking. So last but not least, we are going to do some more partial products problem string. But before we do that, I haven't even talked about our learning intentions for today. So let me go back to that really quickly to show you. Let's see. Yep. So we did a lot of review and we did some do nows, and now we're going to do the meat of the lesson. So today we're going to deepen our understanding of partial products by using the distributive property and the area model. Success criteria. I can solve equations in which I am multiplying one digit number by 2 digits, such as 46 times 4 equals n, using partial products, which I already mentioned earlier. That is a word that I really want us to use. Language intention, I use words from our anchor chart like partial products, distributive property, and area model. Our social intention, as always, as we've been doing during these videos, is I do the work even when no one is looking. So I'm gonna ask you to pause this video right now and to copy this down and give yourself space in between these equations because, yep, you guessed it. You're going to use an area model for each one, and you're going to create a distributive property equation for each one. And we're back. So I'm going to switch screens so that I can write on the board. I just noticed something. Let me see something really fast. Let me see if that works. And if not, I'm going to go back. Can I write on here? I can. Oh, cool. Hold on. All right, cool. I'm gonna just do it on here. I just realized I can write on here. All right, so 16 times 4. We're gonna use that area model, right? So do the first one with me and then you can do the second one. I'm thinking I wanna do my distributive property first. I wanna decompose That's 16, so it's easier for me to multiply. So 16 times 4, I know I'm going to multiply by 4. I'm going to keep the 4 because that's an easy number for me to multiply either way. And I'm going to decompose that 16 into a 10 and into a 6. And I just want to use another color to show you. Here's how I'm decomposing into a 10 and into a 6. So I know 10 times 4 gives me 40, and 6 times 4 gives me 24. And now 40 plus 24 is gonna give me a product of 64. But I wanna use remember I am trying to use the area model, so I'm gonna use a different color right now to show you. So I'm gonna do my area model like this. That's gonna be, and it's kind of hard to do it, guys, not gonna lie. Let me fix that line because that line's very not neat, but you get the idea. Okay, so now I have 4 and I multiplied it by 10. And then I multiply that 4 by 6. Here's my 16 times 4. And we said 10 times 4 is 40. And then 4 times 6 is 24. And we got a total of 64. All right. So now we are going to do the same with 16 times 10. You're going to do it with me, right? And then the last one you're going to do on your own as practice. So whatever I'm writing, you can write. So I'm going to decompose 16 times 10 is the same as, let me decompose that 16 into a 10. And then let's do a 6 times 10. Well, let's see. So I'm decomposed the 16 into a 10 and then into a 6. And I know I have to multiply by that 10. I'm going to use a color just to show you again how I decomposed it. Let me draw that line. So you see I decompose that 16 into a 10 and then into a 6. Okay, now I'm gonna draw here 10 times 10. 10 groups of 10, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I know 10 times 10 is 100. And then 6 times 10, you can do it on the fingers again, but I'm pretty sure we know what 10 times 6 is. It's 60. So 100 plus 60 equals 160. And now again, let's use that area model. Let me see if I have a shape, if I can do shapes up here. Looks like I can't. Can I? Ooh, we can. Okay, perfect. So let's do our area model to show it. And then let me use a different color. Let me see if it lets me do a different color. Yep, perfect. Okay, so now I'm gonna just draw out. Let's draw it out. So we multiplied 10 times 10 and then 10 times 6, right? Here's 16 times 10. We said 10 times 10 is 100. And then we said 10 times 6 is 60. And so we had a total of, our product was 160. Now, I do want you to, I'm going to press X out of here. I do want you to do the third one, which is kind of hard to see, so hold on a second. Let me see if I can go back. Yep. So the third one I want you to do, I'm going to pull this up so you guys can see it, is 16 times 34. I want you to try that on your own. You're going to do 16 times 34. You're going to use that area model and distributive property to solve. And pause so that you can go solve that. All right, so you should be back. So let's do this our last one. Let me see if I can do it down here. I know it's kind of hard to see, but I have 16 times 34. And let's draw on here. I'm gonna annotate. It's not letting me. Come on. Okay, cool. Let's annotate. Let's do, I'm gonna just do it up here, guys, because it's kind of hard to see. So 16 times 34, I'm gonna decompose. What number am I going to decompose? I'm gonna decompose, let's do 34, let's decompose 34. So 34, I'm gonna decompose into, I'm thinking of maybe a way that you guys solved. So we're gonna decompose 16 times. Let's do, we can do 3 ways. Yeah, let's do 3 ways. So 16 times 10 plus, to make it easier, 16 times 10 plus 16 times 10 plus 16 times 4. And let's look at that and figure out why I did that. So I decomposed it a little bit more, so it was a little bit more like a little simpler, because now we're multiplying double digits. And so I'm gonna grab a marker to show you. Let's do another color. So 16, or the 34, I decompose it into a 10, into another 10, into another 10, and into a 4. Do you guys see that? So now I already know what 16 times 10 is because we got it earlier. So really it's 160 plus 160 plus 160 plus now 16 times 4. We'll do that one in a second. 16 times 4, we can decompose it again. Or we know the answer already, sorry. So we already know that's 64. Okay, so now we're gonna solve this. I have 160 plus 160 plus 160 plus 64. I'm looking at my ones. I'm gonna use a different color. I have 0 ones, I have 0 ones, 0 ones, 4 ones. I have 4 ones. Now I'm looking at my tens place. I have 60, 60, 60, 60. So 60 times 4. 60 plus 60 is 120, plus another 60 is 180, plus another 60 would be, 60 times 4 is, or 4 groups of 60 would be 240. So plus 240. And then I have, let me see how many hundreds I have. 100, 200, 300. And now it's going to be way easier for me to solve. So 300 plus 240 plus 4. Let's look. I have 4 ones. I have a 40 in the tens place. And then I have 300 plus 200, which gives me 544. So that should have been your total. I don't have space on here right now to do the area model. I will do the area model in the next video with you guys. I am going to erase this, so hold on, clear all drawings, because the last thing I want you to do, and we'll review it tomorrow, the last thing I do want you to do is to practice a little bit more using the area model and distributive property that we've been using in the last slide. So you're going to write this down: 6 times 30, 6 times 34, 6 times 54. Use the distributive model, use that area model to solve the following equations. And we'll start with this at the beginning of our next video, just to see if you got the answer right. Write a comment down in our video below, something you learned today or something that you found difficult. See you guys in the next video.